Hey folks, welcome. Let's talk about container security. But before going into that, we need to talk about containers. What is a container? If you look at the real world, your day-to-day life, a container is something that holds something else. It holds a receptacle or a good, like your soda can or the airtight container to put your food in. And basically what you're trying to do is making sure that the outside world cannot influence the containment that's inside. One thing is you need to pick your container correctly. However, if you translate that concept into software, people think in many cases that if you put an application into a container, that by default it is safe from outside vulnerabilities, the threats from the outside world. Unfortunately, this is not true. And that's why I am going to show you what you can do to build safe containers. One thing you have to keep in mind is that if you look at a container in real life, it's a protective barrier around the good to protect the goods from the outside influence. However, if you look at software, it's more or less we need two-way traffic. We need to get outside of the container, for instance, having a UI towards any user, or you need to connect to it with a database connection or a request or something like that. So it is different, and we need to cope with that. But first, my name is Brian Vermeer. I'm a developer advocate for Snyk. I am a Java developer by trade. Currently, I'm a Java champion. I do a lot of stuff in the community, and I love that. But today we are going to talk about securing containers, and specifically Docker containers, because Docker is the most used, well-known way to create containers. It is not the only way, I know that. But there are a lot of downloads of Docker containers from Docker Hub. And people create their containers based on that. So today we can more or less say this is a best practice session on Docker image security. Let's get into the first addition, to the first tip I can give you. That is, prefer a minimal base image. If you look at how we build Docker images, we build that in a file, a Docker file. And normally you start with from something. And that from something is, say, from Ubuntu or from Debian or from Node. You built your application on top of an existing image that you probably download from Docker Hub. Last year we did a research, late 2019 we did a research on the top 10 free Docker images that you could use, that you could download from Docker Hub, and we tested them for known vulnerabilities inside the images. And this was the result. All 10 images had vulnerabilities by default. Although most of them are well-known images, well-maintained images that might be certified in some way or recognized by Docker or whatever you might call it. Looking at each and every one of these images, and take specifically the node image, a lot of vulnerabilities come in your application if you just use this image. What we did in this research was we took these images without any specific tag. So basically that means at that point in time, we took the latest image. A lot of people do that and build their image that way. That means that if I do this today, there will probably be a slightly different scale. Moreover, the importance is that the latest image might not be the best image. For instance, if you took the node image and you look at the node image closely, that node image is Node.js built on top of something else, on top of a full-blown operating system called Debian Zeti at that point in time. So that means everything that comes from that layer of abstraction, the full-blown Debian operating system, plus the node image, and then your stuff comes on top of that. So it's layered. And then you have to think about that and think of yourself, do I actually need a full-blown operating system to build my tiny little REST servers on? Probably not. If we take this any further and we look at a full operating system, because most images are built on top of an operating system layer, we see that there are a lot of differences between different operating systems. If you take Debian, for instance, you might use Debian fully, but probably not. If you convert to a Debian Slim image instead of the normal Debian image, you already, remediated a bunch of vulnerabilities. You have less stuff in your image, so that will not harm you. If you go any further to the right on this image, you see that things like Ubuntu or Fedora or even Alpine may help you remediate a lot of threats. So choosing your image correctly, your base image, your foundation of your Docker container, is crucial. Think about it. Do I need every single binary and every single library that comes with a full-blown operating system? Do I need that for my application? Probably not. And in many cases, things like Fedora or Alpine even might be suitable enough. If I translate it to for instance, Java image like here, and I'm using OpenJDK 11, if I do the latest image is bound to the Ubuntu version of this image. And that had, at the point where I tested it, and that's a couple of months ago, was 25 known vulnerabilities in Ubuntu, not so much in OpenJDK. If I choose the Debian version, which I can, which is a far bigger one, it gives me a lot of more vulnerabilities, but also a lot of more, well, unused binaries in my case. Therefore, in some cases, it would be wise to use Alpine. To look at this from an architectural perspective, from the beginning, which choice do I make for my base image is a valid one, because Linux operating system vulnerabilities, they steadily increase. If you see over time how this increases between the different sorts of operating systems, you see that Debian, for instance, in this case is the winner, but that doesn't mean you need to use it. Maybe you do, maybe you don't, but make a conscious choice. Make sure that you only use the stuff that you need, because what you do not have in your container cannot harm you. Let's go to the second option. And the second thing that I want to show you is the least privilege principle, and the least privileged user in this case. Because think about it, the least privilege principle basically says that you can only do what needs to be done, nothing more, nothing less. For instance, if I come to the doctor, I want to make sure that my doctor knows what my medical history is. That doesn't mean that every doctor in the hospital and every nurse in the hospital needs to know what my medical history is. Moreover, if he wants to operate on my nose, he doesn't need to know what my shoe size is, because that's irrelevant. Make sure that you act the same way with users and applications. If you run a Docker image straight away, or you write a Docker file and you just run the application within your Docker image straight away, you run it by default as root. Is that necessary? Probably not. So the best thing you can do is create a specific user for that. Create a specific user with only the privileges it needs. And we can do it something like this. I'm creating an image based on Ubuntu, run my stuff on it, and let me just outline the stuff that is important, because these 3 lines are important in this case. I create a specific user and a specific user group for it. It's a system user without a password, without a home directory, without shell access. And I couple it to the group I created. In the second yellow line, I give it the ownership of my application folder, because that's what I need. I only need the privileges on that folder. In the third line that I marked over here, you see that I call the user, because I can create the user and I can give it privileges, but if I now call the user and use that user I created, it will not do anything and it will still run as root. If I do it like this, then every command afterwards will be executed by the user I created it. So now you see that by doing a few more lines, you add a new user with limited privileges, and that might make sure that your scope is smaller than it was. Because think about security like this. Security is always a chain of attacks. If something happens and that thing, like when you can enter an application or a container in this case, if there's something wrong inside your application or container, we can connect from one step to another step to another step, and you can make it worse and worse and worse and worse. So make sure that in every level or every stage that you can apply secure practices, you should do that to prevent, if something is happening, that it gets blown up in your face. Also, think about the image you're using. I'm now using an Ubuntu image, but if I use, for instance, a Node image, and this is an example from Node 10, the Node images come with a specific user already, the Node user. If I'm not aware of that, and not doing this like the underlined line over here, I'm just using the root user. But if I call that Node user, because it's already there and has limited privileges, I can use it. But you need to call it before you execute the command that you want to command. What you want to do. So be aware of that and find out if your base image or the image that you're using already contains a user that you can use for this instead of creating it. If not, you can recreate it yourself. Next one, finding, fixing, and monitoring open source vulnerabilities in your operating system. Because I told you things like operating systems already. We talked about that in the beginning of picking your base image. But even if you look at build packs like this, you see there is a large difference between where the build packs are used from. So this again is somewhat older research, but just to give you some numbers, it depends on if a build pack is built on Debian or on Ubuntu, for instance. But also it depends over time. So if you test your image from at the beginning when you created it that's already 100 points. But make sure that over time you do that again and again and again, because vulnerabilities will be found and will be fixed over time. There was a question we asked in our open source security report a year and a half ago. When do you scan your Docker images for operating system vulnerabilities? And a lot of people, unfortunately, do not. They do not know, they don't take care of that layer of abstraction. We probably take care of our application, we probably take care of our firewalls and that kind of stuff, but your operating system, if you deliver a complete container, if you deliver a complete image, then you are responsible for that operating system layer as well. So don't input it blindly, make sure that you scan that and you are aware of what is happening. And one thing you can use are applicable tools you can use is, for instance, the tooling that Snyk delivers. And this is an example. If you install the Snyk CLI, so that is, you can find it on the website. I won't go into that. If, say, for instance, I'm fetching the image over here with Docker Pool. I'm Docker pooling the Node 10 container. I can do something like Snyk container test and call that container I have on my local machine. Scan it right away, and it will give you a number of vulnerabilities that are in there, and even give you, for instance, how you can fix them in some cases. If you create a container yourself and you add your Docker file to it, so with a -- file, and you add it to the Docker file that is used to create that container, we can give you remediation advice on the base image, for instance. Like, use another base image to remediate already X amount of vulnerabilities because, well, we know the info. The other thing you can do is testing is good. Testing is good, like when you're building, when you're creating, but also when you're in production, you need to be aware of that. So one thing you can do is doing a Snyk container monitor and monitor that image. What that does is it creates a snapshot of that point in time, sends it over to the Snyk UI, and helps you scan it on a daily basis. It will scan it on a daily basis, and if there are new problems or new remediation advice, it will ping you actively, which is helpful for a development team. Not only pointing out, hey, something is wrong, but also we have a fix. And it looks something like this. I did it for the Node 10 image. I did that today, and you see that over here that we have the amount of vulnerabilities over here. If something is changed, I will get pinged. In this case, my preference is by email in my email box. And that is interesting because did you know that 44% of the Docker image vulnerabilities can be fixed with newer base images? Like, if I just switch out the base image and not doing anything on the application or other key binaries that I might manually put in, but just switching out the base image can already remediate a lot of problems by getting to a smaller base image, by getting to another version of a base image. So if we ask people, how do you find out about new vulnerabilities in your deployed container in production? A lot of people unfortunately don't, because once it's in production, it's basically out of sight, and we're looking at new features. That holds for applications, but also for containers. And know that 20% of Docker image vulnerabilities can be fixed just by rebuilding them. And that is interesting, because in a lot of cases, if you look at Docker images or Docker files, they look like this, like from Ubuntu latest. And you know that the latest now might be different from the latest in 2 weeks or 3 weeks, because once a problem is found, it will be fixed and a new version will be out, and that will be the latest, and so forth and so forth. So doing this, and the same holds for things like I'm doing an apt-get over here on Python. The Python version now might be different from the Python version in 2 weeks or 2 months. This means that if you're having an application, even if the application doesn't change, the shell around it, the container where it lives in, can change by just updating or rebuilding that image. Reuse that Docker file, not doing anything, and rebuild it. Because every time you build it, it potentially can have updates. So best practice in this one is just rebuild it. Over time, once a week, once a month, whatever is feasible for your application, just redo that, even if your application did not change a single character. However, if you do this, a best practice would be to use the --no cache to make sure that it doesn't hit the cache. Normally it shouldn't be doing this, but now I force not to hit the cache anyway, and I force it to download the latest version. So rebuilding it can already solve a lot of things, especially if that container is in production for ages or for months or weeks, but you get me. So, okay, story is enough, but what could possibly go wrong? Interesting question, because when you create a container or you use a container and build on top of that, all the binaries are there. And I'm going to show you an application in just a second that is using one of the binaries that is in that container or on your operating system. And that binary is ImageMagick. And the version of ImageMagick I'm using has an improper input validation. And that sounds okay-ish. But with this improper input validation, I can do code execution. And then it becomes kind of tragic. That's why this vulnerability is called image tragic. I think it's funny. However, I'm going to show you an application in a second, and that application uses image magic. Let me get right to that. All right, I'm running a container. It runs on localhost, and it's here on my machine, and it runs on port 3112. So let's get to here, and you see, let me reload it. This is an application. It's a very simple Node application that uses image magic to where I can upload a picture and it resizes the picture to a ideal format for Twitter. So what I can do, I can choose a file, and let's choose a file on my machine. Let's choose a picture of myself that is large. So I upload it and I say resize, and it resizes the picture to the actual size that is very convenient for Twitter. Okay, cool. So that works. My unit tests around it work fine. But I know this is using image magic under the hood. What if my image was something different? Not just a regular image on my machine, but something like this. Let me go over here. Yes, it's here. rce1.jpg. rce1.jpg. And this is my JPEG. Cool, right? Because this is possible with image magic, or this is valid. The problem is, normally I'm allowed to call the URL within this file. However, with this pipe, I break out of this URL and basically execute touch rce1. So instead of actually downloading the JPEG wherever it is, I am executing a command. And if I can execute this command, I obviously can execute other commands. So if I look in the image is already here, and say something like there is no rce1 file yet. But uploading this image, like I said, let's do this again. And let's choose that rce1 file I just showed you. So rce1.jpg. It breaks out of that URL and it does the touch rce1. So open it, resizes, and nothing comes back because there is no image. And look at what's there. There is an empty file called rce1, so I can do a code execution. And that is interesting because if I can do a code execution like this, I can probably do other codes, create scripts, for instance, or run scripts. Got me? Cool. Second one, I've got something interesting as well. So instead of just doing rce1, I have an rce2. You already guessed it. So if I'm looking at rce2, it does something similar. But what that thing does is it tries to go to a URL, but it breaks out of it again by this quote. Because this quote is something, it basically says like, evaluate this first. And what it evaluates is, I'm going to an address, host docker internal, which basically refers back to the host machine where this Docker image works on. I'm looking for a file, I'm getting the content of that file and print it out in that same file on my Docker machine, so I recreate that file, and I basically run it. So what's in this r.sh? Well, r.sh is a script, and that script gets again to my local host and gets a tarball, netcat. And netcat is an application for networks. Not really important, but it unzips or untars the tarball, and it basically installs netcat on that machine. So by doing this, if this works, I can execute scripts. Cool, right? So first of all, what I need to do, I need to make sure that my local host serves this. Normally I can do something on the outside. So let's serve this application because netcat is in this folder, if I'm not mistaken. Yes, so the r.sh and the netcat tarball is over here. So let's serve this file on port 5000. That's what I need. Address already in use. Oh, right. Let me check. Oh, I did it already in another thing, so I can redo the terminate this one. Cool. I'm back here. It's already in use. It says Now it's not. So it's now listening on port 5000, and it's now serving as a web server. Just a small tool I can use. What I'm going to do is I'm going to upload that RCE2. So going back to the first page, uploading RCE2, and resize it. And it does all sorts of things. You see it's running, but it doesn't do anything. I do need to do something on my local machine. So Netcat is running, but on my local machine over here, let's do it over here. I can do Netcat in listening mode, like LNV on 3131. Just wait a few seconds and let's see what happens. This is on my local machine, and because Netcat is running, this doesn't do anything yet. Nothing yet. Let's retry. All right, I should put it in listening mode first. So let's redo this. First thing I need to do is start up Netcat over here in my local machine and minus LNV 3131. And I'm putting it in listening mode. Interesting. Now I'm uploading that file I just showed you. So I'm uploading that RCE2 file, I open it, and I resize it. And you see it's running. It's downloading the tarball, it's unzipping, etc., etc., etc. So by doing this, I'm executing stuff. And I'm downloading other stuff because, hey, it's possible. So with this listening mode, I basically try to make a connection from my local machine to my Docker host. And you see, by doing an ls, I already have all the files in my root over here. So I now have access, basically some sort of shell access to my local machine, and I can do all sorts of things. But because I can download a tarball, I can execute it by using this construct. I am executing code or scripts on a Docker machine that wasn't designed for that. And that's because we're using image magic that is outdated, that has a problem. So the problem is not so much in my application, but in the binary that is served to me together with my Docker image. So interesting part, take care of that. That's what can go wrong. All right, getting back to my presentation. Next thing, use a linter. And we all know linters from coding. If you are an application developer, you probably use a linter or a source code analysis to write better code, to find bugs, maybe to find security issues as well. And there are also security linters that you can use for Docker files. One of these things is Hadolint or Hadolint. I'm not really sure how to pronounce it. However, it can help you scan your Docker file and see if there are problems or not. If you created a file, you just pull it to this one, just like you do with your application that you use a linter or a scanner for that scans your code to prevent bugs or issues. You can do this with Hadolint as well. And Hadolint can, for instance, tell you like, please use copy instead of add for files and folders because that's better practice. So this is an easy tool again that you can use when creating Docker files yourself to prevent certain silly mistakes. Write that down. Okay, next one. It's not only about your container, because your container is a shell, is a wrapper, and inside your container there's an application. But both cases, like your container is outward facing, but your application probably as well. So think about that. Your application should also be secure. It's not only your application or only your container, it's both. And looking at your application, say this is the binary that you put into that application or into that container. How much of that binary of your application is actually the code that you wrote yourself or your team members wrote? Probably something like this. The rest of it, like the rest of the yellow part, probably frameworks, libraries, other libraries, and we know that libraries, right? So we depend a lot on dependencies that you put into your manifest file, like your package.json or your pom.xml. That's a good choice because we do not want to do the heavy lifting. We do not want to create plumbing like yet another REST endpoint or something like that. We want to create value. And that's the code that we wrote. However, do you know what's in that big yellow ball? What's happening in these dependencies? Because we're responsible for everything. The code you wrote, the dependencies, and the container. So make sure that if you pull in dependencies, that these dependencies are good, that they are not harmful, and that they are up to date maybe. Because if you look at vulnerabilities that are found each year by ecosystem, it is growing, unfortunately. And the point is, it's not so much the dependency that you pull in yourself, but because that dependency that you pull in might depend on something else, on something else, on something else, several layers deep. Most of the problems are in the indirect dependencies, so we should take care of that as well by, for instance, scanning your application. And it again sounds like very theoretical, and what can go wrong with that, right? Well, let me show you. I'm showing you a very small Spring application, and let me get this down. Let me get into the application. This application is quite small. This application is a grocery list. As you can see, when I start this application up, it will fill my grocery list with beans for 50 cents and milk for $1.09. It's Java code. It's not really interesting, to be honest. It's Spring Boot application. This is the item I'm using. The item, this is my domain. It's not interesting at all because these three fields are the most important one. The ID that it's automatically generated, a name, and a cost. The rest of the functions are getters and setters to interact with name and cost. The interesting part comes into the item repository. And the item repository, as you see over here, I am using Spring Data and Spring Data REST. With Spring Data, I can just create an interface, so not even an implementation, an interface extending CRUD repository. And by naming conventions, I can create basic functions like find by name, give it a parameter name, and Spring Data will take care of the rest. It will automatically generate the implementation for me based on all other things like what is my driver, etc. So by doing this, I do not have to implement my SQL query myself. By naming convention, it does it for me. It generates it for me, which is pretty neat because now I can focus on the business value. Cool. With Spring Data REST that I implement or I import over here, I just put an annotation over here. And what I do is from that CRUD repository that connects with my database, I instantly create REST endpoints. So my CRUD repository are available as REST endpoints, which is even greater because now I have the basic functions available and I can work on integration with other things, right? Cool. Very easy prototyping, you would say. So let's run this application and let's hope it works because it's always praying to demigods that these things work. And it works. It's up and running. Let's go back to my browser and let's go to localhost 8080. It refers me to my hell browser, and the hell browser is just to show you how a few things work. Like I can call the /items/1, which gives me the first item in my grocery list, which is beans for 50 cents. If I do number 2, you will get milk for $1.09. Cool. But it can also do things like /search/find by name, which was my CRUD repository and the thing that changed into an endpoint. By giving it a query parameter beer, I can actually search for it. So now I have beer for $5.99. Pretty cool. So we're done. Let's go. But there's a problem in the plumbing. In the Spring Data REST, this particular version is vulnerable. And the vulnerability is not so obvious. So let's go into that. I am in the right thing. Let's go to that application and let's go to the exploits. I will show you what you can do by showing you the JSON body that I can give a certain curl request. It's this body. Let me just enlarge it for you. Let me see what's going on. It is a piece of JSON. And if I put this piece of JSON as part of a curl patch request, for some reason, I am allowed to utilize SPL, Spring Expression Language. With an expression language, I am allowed to call variables, call objects, create new object, that kind of stuff. And what I do over here is I get the current runtime and I execute a command. I get it as an input stream, reroute it to an output stream, and I can show it to you. So if command is something different, not the word command, but an actual command like env or delete or make dir or whatever, and this works, I can basically do anything within the application or break out of the application and do anything on the machine. In this case, your Docker image. So this is cool, but let's just actually hack it. Let's go for the passwd file. So if we look over here, we see that is curl patch request, right? And that curl patch request has a content type, and we see the actual thing over here, like the runtime, getting the runtime, execute. In this case, I'm creating a string that says /etc/passwd. And I call this request with this body on the endpoint item/1. which was there normally as just a get endpoint to get my first item in my grocery list. But unfortunately, I can do a patch request this way as well. And by doing this is of course my local machine. By running this, I will have access to my passwd file. And now my passwd file doesn't contain a lot of information. Luckily not anymore these days. But if I can read this and your Docker container doesn't contain the right privileges for the user, but for instance the root user, we can read and write a lot of stuff in your container without you knowing it. Cool. So take care of your application as well. So I showed you what can go wrong with an application. Next thing I want to tell you is things about multi-stage builds. And multi-stage builds is a marvelous thing in Docker, because what you can do is you can split builds in different steps. And what you can do with that, for instance, is you can divide your build image from your production image. If you look on how-tos on the internet, on Stack Overflow, or when you Google things, you find very small images or very small Docker files how you can build an image. But in many cases, at build time or at creation, you need some more information, and you do not want to leak that into the image that goes to production. With a multi-stage build, you can split these things. And for instance, that's interesting with Java. I'm using a Java image over here. I'm using the OpenJDK Maven 3 image. And that means it contains the JDK, which is the Java development kit. Roughly says it's the JVM plus the Java runtime environment and the building stuff. So what we can do with that is it contains Maven, the complete JDK, and I copy my full source code in it. And I run it. But for a Java application, that's not what I need. I can use Maven, I can use the JDK to build my artifact, and I only need the build result because it's a compiled language. So I do not need Maven and the whole JDK, I just need a runtime environment to run this jar, war, whatever it is in it. You see that because all this tooling is in there, basically you do not just want the car, you want the whole factory to build the car. That's what you're doing here. It's over 600 megabytes. If I do it like this, I still use that same thing as the top part of my build image. So that is the build image as build. And in the second part, I refer to that. So what I do with the second part is I create a production image, and that only holds the Java runtime environment based on Alpine. And that is a very small distribution. That is what goes into the actual product that I'm putting on my server. I copy the jar file and I run it. So that final product will just be over 100 megabytes big. And that's like a lot less. Also, if you, for instance, build node images like here, and I have an example on node 12, a node 12 image, where I need to provide credentials to get to a certain registry. And you do not want these registries, you do not want this token, which is secret. You do not want to leak it into your production image, because if it is there, you can probably find that back. It's somewhere in the cache, and by doing, for instance, history or something, you can retrieve these kind of things. If we do a multi-stage build, everything that is in the build image stays in the build image. And I only copy the stuff over that I need. So things like secrets or extra binaries that you need during creation to check to whatever you want to do, or to do quality assurance, I don't care. Do that in your build part, and you only need the product of it, right? So in this case, the production image is based on, again, node 12, but a slim version, which is a smaller version of it. Separating these two is a very good practice and something you should be doing. So you're using open source. Me too. I'm an open source contributor as well. And open source is great, but you have to make sure that you keep that thing in mind. If a large open source package or container that is widely used is vulnerable and compromised, there are a lot of victims. So as a developer, you're responsible for the application and the container around it to ship it to production. Make sure you are aware what's in it, if there are already known vulnerabilities and how to remediate them. Because you do not want to be eventually secure. You want to be secure as soon as possible, as soon as these vulnerabilities are known. Little recap. Choose the right base image. Make sure that the base image does not contain stuff you don't need. Make sure that it's small, because every binary that ships with a full-blown operating system, you might not need every single one of them. So make it small, make it concise. What you don't have cannot harm you. Rebuild your image often. Even if your application doesn't change, building your image based on a certain base image or other binaries that you pull in they might change and they might have fixes as well. Scan your images during development, but also when you go to production by taking a snapshot and monitor it. Same holds for your applications, of course, but be aware of it that scanning is one of the things that you need to constantly do in every single part of your software development lifecycle. The multi-stage builds I showed you is a good practice to make a separation between your build image that might need stuff like tokens or might need extra binaries to do the building stuff. Separate that from the production image that is small and based on, for instance, an Alpine image or something like that. Use a security linter. A thing like HadoLint that I showed you is a very nice small tool that you can add to your toolset to scan your Docker file and prevent silly mistakes. And last but not least, make sure that you do not run your Docker container as a root. By default, this is the case, so create a user or make sure that if the container you base your image on, if it already has a specific user, that you actually call it, but don't run it as root. All right, that's about it for me. Thank you for listening. Thank you for watching. All the tooling I showed you, you can use for free, and see you later. Cheers.